Now we're going to prove the cosine rule. So this is the cosine rule here. So in order to prove the cosine rule, we're going to need to draw axes. So a y-axis and an x-axis. And we're going to draw construct a circle with the center being the origin. So that's our circle here, and we're going to draw out, so from the origin to the center, which is going to be the radius of our circle, and the radius, we're calling it B. And then this is going to be a point on our circle, and we're also going to put a point, call this Q, that's outside our circle, and we're going to join these 2 points together. So this Q is outside of our circle, so the length, the x value of Q, the x coordinate, is not going to be the radius because it's larger, the distance out to Q is. So we're going to call this C, and because it is on the x-axis, the y coordinate is going to be 0. So Q is C0. So P, if we consider a triangle, say if we had a triangle here, this would be the opposite, so the y value would be the opposite and the x value would be the adjacent. So if we want to get the x and y coordinates of P, well, the adjacent, if we were to get, so say this is opposite, hypotenuse and adjacent, so if we were to get cos of that angle, it'd be the adjacent over the hypotenuse. So the adjacent would be equal to the hypotenuse by cos of the angle. Similarly, the opposite is equal to the hypotenuse by sin of the angle. So in this case, our adjacent is our x coordinate. So it's going to be the hypotenuse, which is B, by the cos of our angle. And we're going to call this angle A. And then B sin A. So that's the coordinates of P. And this, our center, is 0, 0. So now we're going to use our distance formula to get the distance from P to Q. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So we're going to call this our x2 and our y2 because we're going to subtract minus c and minus 0. So it'll be easier for us this way. And because this is angle A, side A is going to be opposite it. So PQ is going to be x2 minus x1. So x2 we're going to call is going to be, so this is x2 y2 and this is x1 y1. So x2 is B cos A minus x1, so minus c squared, plus y2, which is B sin A minus y1, so it's minus 0 squared. So then when we have this, so that's going to be our PQ. And we're also, we can also see from the diagram that PQ, the distance from P to Q, is equal to A. So PQ is equal to A. And also, PQ squared would be equal to A squared then, because if they're the same. Because we want to try and get rid of this square root. And if we were to square both sides, we'd be able to get rid of that square root. So PQ squared is equal to A squared. So if we were to get PQ squared, then we could get rid of our square root. So it'd be B cos A minus C squared plus B sin A squared. So that's PQ squared. Our square root is gone. So PQ squared is going to be the same as A squared. So we can then let A squared equal to this in place of the PQ squared. So B cos A minus C squared plus B sin A squared. So now we're going to try square out this. So we have to multiply out this bracket. So it's going to be B squared cos squared A, and then minus 2bc cos A, and then plus c squared, and then we'll have plus b squared sin squared A. So now we have to try and sort this out. So we have to remember that cos squared of an angle plus sin squared of an angle is equal to 1. So we can group then this and this together. So we can go a squared is equal to b squared cos squared A plus b squared sin squared A minus 2bc cos A plus c squared. So we can take out a common factor, b squared here. So b squared is equal to cos squared A plus sin squared A, and then minus 2bc cos A plus c squared. So we know that this is equal to 1. So a squared is equal to b squared multiplied by 1, which is just b squared, minus 2bc cos A plus c squared. And then we can just move the c to here. So a squared is equal to b squared plus c squared minus 2bc cos of A. And that is the proof of our cosine rule. So what we have to do, firstly, get the distance from P to Q, then square it to get rid of our square root, and then instead of PQ, we're going to put in A.